Assalamualaikum. My name is Samreen Zara, registration number 21TE103. Today I am going to perform the lab number 3 of digital signal processing. The main objective of this lab is the representation of unit impulse, unit step and exponential signals, and making the signals out deltas. Now moving toward the task number 1, which is about the impulse sequence. Here first we can define our impulse sequence function. In this function we have set up our two limits n1 and n2, and n0 is the index value. Now see the example of unit impulse sequence. This example will show us the impulse sequence function. So -5 to 5 are the limits and 0 is the index values. So we can run the function to see the result. The plot command will give us this original impulse function, and the stem command will show this impulse sequence graph. Now moving toward the task number 2. Task number 2 is about the step sequence function. Similarly, we can define our step sequence function. N1 and N2 are the limits values and N0 is the index value. Let's see the example of step sequence function. In step sequence function, -5 to 5 are the values, limit values, and 0 in the index values. We can run the program to see the output. So plot command will give us this original step function, and the stem will give us the step signals in the digital form. So moving toward the task number task number 3. Task number 3 is about adding the shift impulse. We can use hold on and hold off command by adding the shift impulse to our given signal. So we can define our limit values -10 to +10, and using the deltas we can generate our output signals. We can use two different subplot commands, so we can check the output value. This is the output of the given unit impulse sequence function. As we know that the unit impulse will give us the output value at only a 0 point, otherwise it will not give us a signal. So first we are showing the original impulse sequence, and this is the shifted unit impulse sequence. So task number 4 is about the shifting of unit impulse function. Similarly, we can initialize our impulse signals using the deltas and using the hold on and hold off command. We can generate our output signal. And this is the representation of the continuous time signal graph. Task is about the separation of even function and the odd function of the signal. So we can M is for the original values for original signal, and M1 and M2 are for the even and odd signals. In the same figure you can see that first figure is for the original signal, continuous signal, and second signal is showing the even and odd values. So the after this red spot we can this is the even values of our continuous signals, and before the red spot these are the odd values for the given continuous signal. Last task number 6 is about converting a continuous signal into the digital form. So we can define a time period from 0 to 2 and the time delay of 0.005, and the continuous signal is cos 2 pi f of t. We can use the subplot commands and give a title to our graph and label my x and y axis. So we can run this program to see the output. So this is how you can convert a continuous time signal into the discrete form. Thank you so much, and Allah Hafiz.